Hello again, Raiders. Today we are talking about dilutions. And dilutions are ways that we can alter the concentration of solutions that we have. And so remember that concentration is the number of moles of solute, the thing that we dissolved, in the final volume of solution. Note that the volume of the solvent is not specified. It's just how much of the particles are in the whole mixture, the solution. And so the reason why is because if we look at how we prepare a solution from scratch, we would measure in mass, grams, which is why even though our formula for molarity is moles over liters, we still have to know how to convert from mass to moles, because we can't measure moles in the lab. We can measure grams with a scale. And so what we're doing is taking a certain mass of a solid, we're putting it into a container, a volumetric flask, which has a mark at a certain volume. And for example, this one is 250 milliliters. So if I want 250 milliliters of a solution, you might think that I would have to add 250 milliliters of solvent. However, if we did that, then it would overflow. It would go above the mark. So here we've added some of our solvent. The powder already takes up some space. And so in this example, we have about 45 milliliters left over. So that's why we always look at the volume of the solution, that whole mixture together, when we're talking about concentration. But sometimes we have certain solutions that are at concentrations that we don't need. And so we need to have ways that we can dilute them down so that the concentrations that we do have are safer to work with, but will still work in our experiments. And so that's where we have these situations where we start off with a stock solution before dilution. And if we use this model, we can see that there are 6 particles in this stock solution. And if we add water to that, just pour some water in there, we do not change the number of particles. They're still 6. So they contain the same number of moles of solute. What we have changed is the volume that those molecules are floating around in. And so remember that molarity is moles per liter. It is a ratio, and we're not changing the number of moles that we have. We're changing the volume that those moles are sitting in. And so we're changing the ratio that they're in and making it so that they're less compact, less concentrated. All right, so take the time to copy this down in your notes. This is a diagram. It is a picture with labels. Get this down into your notes. The more visuals you have, the better you'll remember the information. So we need to get that down into our notes. Okay, and continuing with those notes, solutions and dilution. What does dilution mean? Well, it means to make something less concentrated. Right? So make sure that we're getting these down. This goes perfect in Cornell note format. So how can a solution be diluted? Well, that's easy. We just add more solvent. Most of the time that's water. Doesn't change the number of moles, but it changes the volume those moles are sitting in, and therefore it changes that ratio of moles to liters. What happens to the original concentration? It's reduced. It gets decreased. It lowers. Calculations. So, yay, another easy formula, easy math. Wonderful. This is M1 V1 equals M2 V2. And you're going to be given enough information that you will only be solving for one of these variables. And so this is really easy because whatever you're looking for, you just divide what's next to it. Do that to both sides, and there you go. That's all you need to do. We'll work some examples here in a second. All right, so in these formulas, and you should always be writing this formula down for every problem, M1 is the original concentration. It's your stock solution. And they're not always going to label it. In fact, most of the time, they won't label it M1. You're going to have to be able to tell from reading the problem what your starting concentration was. V1 is the original volume of solution that you need for the dilution. Okay, so it's the volume of your original solution. And that can actually be in milliliters or liters. It doesn't have to be in one or the other. If you start off with a volume in milliliters, you can keep it in milliliters. Your answer is going to be in milliliters, and if they don't ask for anything else, that's fine. If they do ask you to put it in liters and they give you milliliters, well, then you'll have to convert. But you don't have to do that necessarily unless they specifically ask. So that's another easy thing about the formula. M2 is the concentration after dilution. So it's the ending concentration. And V2 is the volume of your new solution after it's been diluted. Again, either milliliters or liters. And that does kind of bother me that says capital ML, it should be little m. But I'm borrowing this from slideshare.net, so we'll live with it. In your notes, though, do make sure that you have lowercase m, because that would be proper. Okay. There's just another visual. So if we had a stock solution that was too concentrated, we would use a pipette or some other device to take that solution out. So, and this is the empty flask that we're going to put it into. In this second picture here, we have moved this pipette over to the empty flask and we are starting to dispense our stock solution. We're going to add solvent to that flask until it reaches up to that volume that we need of our final solution. Okay, so practice problems, here we go. Write down the problems so that as you're writing your notes, you know where these numbers are coming from that you're writing down. How do you prepare 250 milliliters of a 2.35 molar hydrofluoric acid dilution from 15 molar stock solution? Okay, and these are together. It's this volume of this solution, and this is a dilution, which means that that is my final or my second set of measurements. So this is going to be my M2. I know it's molarity because it has the M, and this is milliliters, so that's going to be my volume 2. And what I'm starting with is my M1. And your stock is always going to be more concentrated than your dilution. So that's going to be a way to make sure that you've got the correct M1 and M2. Your M1 should always be more concentrated because that's the thing that you're trying to make less concentrated. That's what you're trying to dilute. Okay, so that means the only thing I don't know is my V1. And notice it doesn't just ask for V1, it says how do you prepare the solution? All right, so we'll look at that as soon as we figure out how much of the V1 we're going to need. So write down your formula. M1 V1 equals M2 V2. We're solving for V1, so let's isolate that by dividing by M1. Got to do that to both sides. So V1 equals M2 V2 over M1. All right, plug in your values. We'll check your answer here in a second. All right, so after plugging everything in, I see 3 significant figures in each of my measurements. So I'm going to round my answer to 3 significant figures as well. 39.2 milliliters of the stock solution. Okay, so back to the question of how do I make my 250 milliliter dilution? So what that means is that I want to end with 250 milliliters. I'm going to take this amount to start with. So how do I get down there? How do I get down to up to my 250 milliliters? Well, we're going to come back to this. So this is going to be right here, my 39.2 milliliters that I'm then going to transfer to an empty flask. So this is being dispensed into the flask. And I'm going to put it up to the mark there so that this is 250 milliliters. All right, let's just say that's our 250 milliliters. And this was our 39.2 milliliters. Okay, so how much solvent do I need to add? Because that's what's going to bring it up to the mark. I have a very small amount of my concentrate. I need to dilute it up to the mark. So how much is going to be water? Well, all we have to do is subtract. I know that I need 250 milliliters total. I know that so far 39.2 milliliters is my concentrate. So I just subtract to see whatever's left. That's going to be my solvent, the water. And that comes out to be 210.8 milliliters of water. And so that's how you would make the solution. You would take 39.2 milliliters of the stock, add 210.8 milliliters of water to make your final solution. Okay, let's do another one. Let's do number 2 next. If 455 milliliters of a 6 molar nitric acid, that goes together, if that is used to make a 2.5 liter dilution, so my dilution, that's always my second set. This is liters, that's volume, so I know that's volume 2. What is the molarity of the dilution? So what is M2? That means this is V1 and this is M1, but I see a problem. V1 is in milliliters, but V2 is in liters. So I'm going to have to convert one of those to make sure that they're both in the same unit. I'm just going to convert 455 milliliters. I know it's 1,000 milliliters for every 1 liter, so that gives me 0.455 liters. Okay, so make sure that you have that written down. That's some of the conversions that I need to see, some of the work I need to see in your problems. So now we can use that in our calculation. Okay, so my formula, M1 V1 equals M2 V2. I am looking for M2. So let's isolate that variable here. M2 is being multiplied by V2, so let's divide by that. That means that this is the formula I'm working with, M1 V1 over V2. And now I can plug everything in, pause the video, calculate, check your answer. Okay, and I see 2 significant figures. That's my lowest number of significant figures, so my answer will be 1.1 molar, and this is HNO3. That's my final concentration right there. Okay, so let's do problems 3 and 4. I'm going to let you work them on your own. I'll show you the answers one by one, so pause the video, work it out, and then check your answers. Okay, so number 3, you should get 4.64 molar. All right, do number 4, and here is your final answer. You are now ready for homework.